Now see next topic, properties of determinant. So with the help of these properties we can evaluate a determinant easily. So we discuss first property, the value of determinant remains unchanged if its rows turn into columns and columns are turned into rows. So with the help of this example we verify this property 1. Here this property states that if we interchange row with column, then the value of new determinant remains unchanged. Suppose here given determinant is A. If we interchange the row elements in column, that is we turn rows into columns. See here, if the given determinant is A equals to, and if we interchange the row with column, so we write that determinant as A1. So the element of first row we write in first column. So write here 1, 2, minus 1. Then elements of second row we write in second column. So 3, minus 1, 2. And elements of third row we write in third column. 0, 2, 1. If you observe, indirectly the column elements changes to row elements. Here see, elements of first column are 1, 3, 0, that changes to first row. That means if we turn row into columns, indirectly the elements of column turn to row elements. So if we calculate the value of this determinant A and calculate the value of determinant A1, that must be same by this property 1. So we state first property as the value of determinant remains unchanged if its rows turn into columns and columns are turned into row. So by expanding this determinant A and A1, we verify the property 1. So first we calculate the determinant A here. So for that we solve along first row, second row or third row. So we solve along first row. So write minus plus minus. So write here 1 in determinant. When we consider first row and considering first element, we skip that first row and first column. So we write here in multiplication to this 1, determinant having element minus 1, 2, 2, 1. Then here minus 2. Then we skip first row and second column. So write here elements in the elements of this determinant as 3, 2, 0, 1. Then plus minus minus in a determinant we write elements, we skip first row third column, elements as 3 minus 1, 0, 2. 3 minus 1, 0, 2. Now calculate this value. Minus 1 into 1 we get minus 1, 2 into 2 4. So 1 minus 4, minus 2 in bracket, 3 into 1 3, minus 0 into 2 0, minus 1 in bracket, 3 into 2 6, minus 0 into minus 1 we get 0. So here 1 in bracket, 1 minus 4 which is minus 3, minus 3 minus 0 we get 3. So 2 into 3 minus here 1 into 6. So here 1 into minus 3 we get minus 3, minus 2 into 3 we get minus 6, minus 1 into 6 we get minus 6. So here minus 3 minus 6 minus 6 we get here minus 15. So calculate this value. 1 in bracket, minus 1 into 1 we get minus 1, minus 2 into 2 4, minus 2 in bracket, 3 into 1 3, minus 0 into 2 0, minus 1 in bracket, 3 into 2 6, minus 0. So here we get 1 in bracket, minus 1 minus 4 which is minus 5, minus 2 into 3 into 0 is 3, so 2 into 3, minus 1 in bracket, 6 minus 0 is 6. So we write here 1 into minus 5 as minus 5, minus 2 into 3 as minus 6, minus 1 into 6 6. So we get here minus 17 as the value of this given determinant A. So after interchanging the row with column, we get here determinant A. We have to verify A equals to A1 or not. So for that we calculate this determinant A1. So write plus minus plus here. So we write 1 in a determinant. So for this one we skip first row first column. So write the value of or write the elements of this determinant as minus 1 to 2 1. Then minus 3 in a determinant, we skip first row second column. So write 2 2 minus 1 1. Then plus 0 in a determinant, we write here, we skip first row third column. So write 2 minus 1 minus 1 2. Actually there is no need to write this determinant. We get value of this in multiplication 0. So we get third term as 0. So for your practice you have to write this determinant. Then 1 in bracket, minus 1 into 1 we get minus 1, minus 2 into 2 we get 4, minus 3 in bracket we get 2 into 1 as 2, minus and this minus sign, so minus minus get plus, 1 into 2 we get 2 plus 0. So write here minus 1 minus 4 as minus 5, minus 3 in bracket 4. So we get here minus 5 minus 12 which is equals to minus 17. So we denote this as equation number 1 and this as equation number 2. So from 1 and 2, therefore we say A is equals to A1. That means after interchanging the row and column, we get the same value of that determinant. So this is first property. Now see second property. If any two rows or columns of the determinant are interchanged, then the value of determinant changes its sign. Now here we calculate the value of this determinant A, which we get minus 17. But when we interchange any two row, this is first row, second row, third row. When we interchange R1 with R2 or R1 with R3 or R2 with R3, then the value of this determinant changes to its sign only. That means here if we interchange R1 with R2, then we get value instead of minus 17, we get value plus 17. Or we can interchange the columns also, C1, C2, C3. If we interchange any two columns, C1 with C2 or C1 with C3 or C2 with C3. So interchange of row or column write as R1 interchange with R2, R1 interchange with R3, R2 interchange with R3. So this read as R1 interchange to R2, this symbol for interchange. And similarly for column we write C1 interchange to C2, C1 interchange to C3, C2 interchange to C3. So in this way, if we interchange the column, which row, which column we interchange, right here. So we verify this property with the help of this determinant A. Suppose we interchange these two row R1 with R2, then we write here A1 as, or we can write here R1 interchange to R2 and A changes to, you can write A changes to determinant. So we have to interchange the elements of second row and elements of first row. So after interchanging we write this A changes to as 3 minus 1 2. We write elements in second row in first row and elements of first row in second row. So right here 1 2 minus 1 and keep this third row element as it is 0 2 1. Now we calculate the value of this determinant and we have to check this property. That means after calculating this determinant we get value opposite to this side. That means here sign is minus 17, and after interchanging two rows we get value as plus 17. So we calculate this plus minus plus. So write here 3 in determinant, 2 into 1, or you can directly write the value, or first we write the determinant. So 2 minus 1, 2, 1. Then minus minus get plus 1. In determinant we get 1 minus 1, 0, 1 plus 2. In the determinant we skip third row, first row third column. So write in determinant 1, 2, 0, 2. So write 3 in bracket, 2 into 1 is 2, minus minus plus, 2 into 1 is 2, plus 1 in bracket, 1 into 1 is 1, minus 0 into 1 is 0. So write minus minus plus 1 plus 0, plus 2 in bracket, 1 into 2 is 2, 0 into minus 0 into 2 is 0. So write 2 minus 0. So here we get value 2 plus 2, 4, 3 into 4, plus 1 into 1, plus 2 into 2. So 3 into 4 we get 12, plus 1 plus 4, which is equals to, so 12 plus 1 13, 13 plus 1 14. That means here sign changes. So similarly you can check for the interchange of R2 with R3 or R1 with R3, or you can check for the column interchange C1 with C2, C1 with C3, or C2 with C3. You will get the same value, that is plus 17, for interchange of any two row or interchange of any two columns. Now see third property, if any two rows or columns of a determinant are identical, then the value of determinant is 0. Now see here example, A equals to, in first two elements are 1, 3, 0. In second row elements are 2, minus 1, 2. And in third row elements are 2, minus 1, 2. That means these two rows R2 and R3 are identical. That means if we calculate the value of this determinant, that value must be equal to 0. So we expand this determinant and verify the property here. So write here plus minus plus. So we write plus 1 in determinant. We skip first row, first column. So write in determinant minus 1, 2, minus 1, 2. Then minus 3 in determinant. We write here after skipping first row and second column element as 2, 2, 2, 2. Then plus 0 in a determinant, we write here 2 minus 1, 2 minus 1. So calculate this, 1 in bracket, minus 1 into 2 we get minus 2, minus, and this minus sign, so minus minus get plus, 1 into 2 we get 2, minus 3 in bracket, 2 into 2 is 4, minus 2 into 2 is 4, plus 0 in bracket, 2 into minus 1 is minus 2, minus, and this minus sign, so minus minus get plus, 2 into 1, 2. So we get here 1 into 0, minus 3 into 0, plus 0 into 0, which is equals to 0. That means if any two row or any two columns are identical of given determinant, then the value of that determinant is 0. That means you have to check whether the given row or columns are identical in the given determinant, and from that there is no need to calculate the value of determinant. If you observe that any two or any two columns, any two row or any two columns elements are identical, then from that you can say the value of that determinant is 0 without calculating the determinant or without expanding the determinant. Now next property, property 4. If each element of a row, here underline this word, a row, that means we consider here single row or single column. So if each element of a row or a column of a determinant is multiplied by a constant k, then the value of determinant is k times the value of given determinant. That means when we multiply any row, we consider here single row. Suppose we consider this row R1, and if we multiply by k to each element of this row R1, then the value of new determinant we get k times the value of this given determinant. Suppose we consider here determinant A, and the value of this determinant we already calculated, which is minus 17. Now we multiply this first row by k, or instead of k we take k equals to 5, or we take for convenient k equals to 2 here. If k equals to 2 and we multiply first row by 2, so right here 2 into R1, and this A changes to. So we multiply each element of first row by 2. So 1 into 2 we get here 2, 3 into 2 we get 6, and here 0 into 2 we get 0, and write the remaining elements as it is. 2 minus 1 2 minus 1 2 1. Now we calculate this determinant. So right here plus minus plus. So plus 2 in determinant, we skip first row, first column, and write the elements in this determinant as minus 1 2 2 1. Then minus 6 in determinant we write here after skipping first row, second column, elements in this determinant as 2 2 minus 1 1. Then plus 0 in determinant we write elements as 2 minus 1 2 after skipping first row and third column. So calculate this value. 2 in bracket we get minus 1 into 1 as minus 1 minus 2 into 2 4 minus 6 in bracket 2 into 1 is 2 minus this minus sign, so minus minus get plus 1 into 2 2 plus 0. So 2 in bracket minus 1 minus 4 we get minus 5 minus 6 in bracket we get 2 plus 2 4. So here 2 5s are 10, so write minus 10, 6 4s are 24. So we get here value minus 34, which is equal to 2 into minus 17. That means here after multiplying k equals to 2 to each element of first row, we get the value of new determinant, which is multiple of 2. So here 2 into minus 17. So in this way we verify the property 4. Now see property 5th. If each element of a row or a column is expressed as sum of two numbers, then the determinant can be expressed as the sum of two determinants. Now consider here example, given determinant as A, and elements of first row are 4 3 5, elements of second row are 2 minus 1 2, and elements of third row are minus 1 2 1. Now first we discuss property 5th. What this property 5th state? If we write any row elements as sum of numbers, now see here we write this 4 as 2 plus 2, we write this 3 as 3 plus 1, and we write this 5 as 2 plus 3 suppose. Then you can take this 2 plus 2 as 3 plus 1 also, 1 plus 3 plus 1, 1 plus 3, this 3 as 2 plus 1 or 1 plus 2, and this 5 as 4 plus 1, 2 plus 3. Now suppose we write this 4 as 2 plus 2, 3 as 2 plus 1, 5 as 2 plus 3, and keep the second row, third row element as it is. 2 minus 1, 2, minus 1, 2, 1. Then we express this determinant as sum of two determinants, and we write that two determinant as so take this 2 then this 2 and this 2 in first row, and keep second row, third row element as it is. 2 minus 1 2 minus 1 2 1. Then in second row we write 2 1 3 2 1 3, and second row, third row element as it is. 2 minus 1 2 minus 1 2 1. So you calculate the value of this determinant A, then you calculate the value of these two determinants. Suppose this determinant is A1, this determinant is A2, then you get the value of determinant A equals to sum of these two determinants value A1 and A2. So you check yourself, you find value of A, then find value of A1, value of A2, then after adding this A1 and A2 determinants value, you get value equals to value of determinant A. Now see property number 6. If a constant multiple of all elements of any row or column is added to the corresponding elements of any other row or column, then the value of new determinant so obtained is the same as that of original determinant. Now we discuss this property with the help of this example. Now suppose given determinant is of order 3 by 3. Here when we multiply by any row element by any constant, and if that multiplied value added to any row, we get the same value as the value of this determinant A. Suppose given determinant is A, and we already calculate the value of this determinant, which is equal to minus 17. Now we multiply value of this determinant is minus 17. We multiply this first row by 2 and added that value to row R2. So we write this as, we write here R2 changes to, or R2 changes to 2 times R1 plus R2. That means we multiply the elements of first row by 2, and that corresponding value add to the corresponding elements of these elements of row R2. Now see here we multiply by 2 to each element of row 1. So 1 into 2 we get here 2. Then we add with element of R2, that is 3. So 3, 2 plus 3, we write here 2 plus 3. Then 2 into R1, R1 is 2. So we write here 2 into 2, 4. 4 plus minus 1. Then we write 2 into minus 1. So we get here minus 2 plus 2. Now we change to R2. You can write this as R1 change to, that means when we write value in first row, we have to write here R1 change to 2 times R1 plus R2. When we write here R2 change to, then you have to write these elements in second row. If we write here R1 change to, then we have to write that element you change in first row. If we write here R2, then this is element of second row. So we write this as 2 plus 3, 5. Then 4 minus 1, we write a 3. Minus 2 plus 2, we write a 0. And these are the elements of second row, because we write here R2 changes to. If you write R1 changes to, then you have to write this value in first row. So keep first row as it is 1, 2, minus 1, and third row as it is 0, 2, 1. Now calculate this determinant, plus, minus, plus. So we get here value as 1, and we directly calculate the value. We skip first row, first column, and calculate the value of this determinant. 3 into 1 is 3, minus 2 into 0 is 0. Then minus 2 in bracket. We skip first row, second column. So 5 into 1 we get 5, minus 0 into 0 we get 0. plus minus minus 1 in bracket we get here. We skip first row, third column, so 5 into 2 we get 10 minus 0 into 3 we get 0. So calculate this. 3 minus 0 is 3. 3 into 1 we write 3. 5 minus 0 we get 5. 5 into minus 2 we get minus 10. Then 10 minus 0 we get 10. And here 10 into minus 1 we get minus 10. So write here 3 minus 10 minus 10, that is 3 minus 20, which is equals to minus 17. That means this property is verified. That means here we multiply this first row by 2, and after multiply by that constant to each element of first row, add that value to the elements, corresponding elements of second row, and we write this determinant and expand this determinant, and its value we get minus 17. So we write here, if a constant multiple of all elements of any row or column is added to the corresponding elements of any other row or column, then the value of new determinant so obtained is the same as that of original element. Now last property, this property we call triangle property. If each element of a determinant above or below the main diagonal is 0, then the value of determinant is equal to the product of its diagonal elements, that is. So first we discuss what is diagonal. So if given determinant is of order 2 by 2 and elements are A, B, C, D, then AD, this is first diagonal, elements are A and D. If we consider this diagonal, then elements of this diagonal are C and D. This is for 2 by 2. Here this property states that if the elements above any diagonal, so here we consider this A1, B2, C3 as diagonal, then each element above the diagonal, so see here, this element is 0, this element is 0, this element is 0. That means all the elements above the diagonals are 0. Then the value of this determinant is product of the elements of this diagonal. That means A1 into B2 into C3 is the value of this determinant. Or if this determinant is like this, A1, A2, A3, B1, B2, B3, C1, C2, C3. If we consider this diagonal, and instead of B1 value is 0, instead of C2 value is 0, instead of C1 value is 0, then the value of this determinant is also A1 into B2 into C3. That means product of the elements of the diagonal. So this property is very important while calculating the value of determinant. When we discuss upper triangular matrix, lower triangular matrix, at that time we calculate the value of that matrix with the help of determinant. So this property is useful that time while finding the inverse of the matrix. So remember this property. You can take any example and first calculate the value with the help of plus minus, plus then calculate the value of that determinant with the help of this property, and you can verify this property.